Wednesday, when you show up, we'll have what should be a short quiz on the homework. The articles are here. Recommendations for studying are here. It's not going to follow the homework 2 template exactly, but you're looking for the same things. What I would do is fill out a table for the 3 articles, model the article 1, 2, 3, then you'll have replication, standards, line, random, etc. And I just kind of lift quotes out of the article. Once that table's in place, then you're good to go. Just sort of look at that. You'll show up. You'll look at your EID. You'll look at what article you're supposed to choose. It might be that one for you. It might be it'll be one for someone else. And you aren't going to have this table in front of you, but you're going to go through a set of options. And the options are, there's 6 or 7 of them per question. I guess if you have fewer. And you're going to be asked to evaluate a statement. So there's going to be 2 relevant options per article under each question. So you'll just go through and say, okay, that one's relevant to my thing, that one's relevant to mine, the others aren't. You choose between them. In some cases, oh yeah, explicit protocol. In some cases, you're just going to look at a quote and you'll decide, okay, does that actually describe explicit protocol, or does that do something? I mean, you won't even have to know much about the article to answer the question. In other cases, you're going to have to know what the sample size was, things like that. So just, pull quotes out to fill the table, study the table, and I don't think it'll take that much effort, but I don't know. I've never done it before. We'll see how it goes. That's why you get to drop 1 out of 5 homeworks. What? You can't tell that's random? Oh, God. Okay. I'm kidding. I can't tell that it's random either. Doesn't matter, right? This is the homework. These are the items in the homework 2 template. So you've already done homework 2, presumably. All you're doing is, you're applying this to 3 other articles, and then when the time comes, you are going to apply it to 1. And you don't get to bring the article in. It wouldn't be a good idea to have your phone out, etc., because, of course, I guess I could kill those links, couldn't I? Okay, not going to go there. And then we're going to have a lecture, right? This is not the only thing we're doing Wednesday. Back to where we were Friday. It was on correlation, and I realized after you walked out of here, in response to your questions and such, that maybe the last thing we ended on was confusing. So I sat down and I thought about it, and I thought about it, and I thought, yeah, well, maybe that could be confusing. I ended up talking to one of my colleagues to sort of help me explain things and actually help me understand things. This guy's PhD is in theoretical physics, and he teaches the biostats course. And he said correlations are one of the hardest things for his students to understand. Now, he's teaching the math behind it. I'm not. But so I'm going to spend some more time going over this today. And I'm going to give you 2 ways of figuring out whether a correlation is possibly present. So what is needed for a non-zero correlation? And I've not put this in the notes before. Well, it's not in them now either. You must either have, or how about have either, 1, measured the same 2 variables on different individuals Examples could be hair length as one variable, gender is a variable, SAT score would be a variable, assuming that, of course, individuals in your population do indeed differ. Body weight, you know, each of those could be variables. Or measured the same variable on two populations or entities. So those are what we would call necessary conditions, and I'm saying that just to sound, I guess, impressive. But then, once you've satisfied those, for the correlation to be non-zero, the two variables or must change together, or one population differs from the other. On average. So this number 3 I emphasized last time. What I didn't emphasize was how you actually can sit down and crank through this and decide, do I have 1 and 2 tell you what, you know, if you have enough information for a correlation. Yes. Yeah, so for example, you could measure hair length and gender. These would be on the same two individuals, and then say there's a correlation between hair length and gender. Is that what you're asking? Is that better? When I say different, I mean you have to have more than one individual that you measure two variables on.
Okay, I was wondering if you had to have 2 separate groups.
You don't have to. So in this class, we could measure hair length and fingernail color or something like that on every individual, and then we could ask if there's a correlation. And that's actually the standard sort of thing that's done. So let me go back to where we ended. So look at these in your notes and start trying to apply them. You got those copied down, I assume. I'll reread the intro to the question. Which of the following statements describes a non-zero correlation? Do not choose an option that describes a zero correlation, for which correlation is defined, for which describes causation but no correlation. If insufficient information is given to determine whether correlation exists, treat it if there is none. If part of a group is described as having some attribute, assume the others in the group do not have it. So I believe this is the one that we ended on Friday. 65% of the students enrolled in Bio 3.1D are men, 35% are women. Focus on that. Now we'll let you choose, and I've now expanded your choices, because what I want to do is want to get a sense of how confident you are in your answer here. And there were some interesting things last hour. So we got, oh, I've already erased them. I'll go back to the statement in a minute. But let me put these options up. True, 32, 9, 129. then false, same as last time, the first number. I'm actually a big fan of chalkboards, but especially when they work. I don't know if you can read those from the back or not. If not, just guess. So look at the criteria I just gave you, 1 and 2, and see if you can bash that statement into satisfying either of them. And then vote. Yes? The top one's the one with confidence. And it doesn't really matter, right? But it's for me to get a sense of how, whether you think you know the answer or not. If everyone's not confident, then I know you're just guessing. As opposed to, never mind. And you're free to talk about this. Yep.
So are there a correlation and a non-zero correlation?
So you've got, when you have a correlation, you have x and y. If you change one of these, the other changes on average, then you have a non-zero correlation. If you're to graph things, even if it's categorical, if you have, say, a mean here and a mean here, as long as the line is not horizontal, then you have a non-zero correlation. A zero correlation is when the line's flat. You guys did a lot better than last hour. What? I think I went over it in the other class last time, too. Maybe it's the extra hour of sleep you guys got. Good. Okay, that'll mean we're out of here 15 minutes earlier. Oops. Well, assuming I'm competent enough. This one is, I would consider to be a challenge. This, use whatever means that are at your disposal to sort this through. 35% of UT students have blood type A, 20% of those are A+, 80% of A-, 80% are A+. I've got to clear out the poll. So same numbers. Actually, I probably should have gone over that. We'll go over that previous one most you got right anyway. So what you're telling me is that you wouldn't have gotten this right if we hadn't gone over it Friday. I'm trying to play here. So this one's challenging. We want to look at which screen is more entertaining, this one or the previous one. We didn't go over this one Friday, and you still got it right. Mostly.
I guess there is no correlation.
So let's dissect these. So last hour is a dead heat between the two choices. Now I realize not all of you are getting this right, but so let's start with the previous one and dissect it along the lines of what I was telling you at the beginning of class. 65, so you got two ways to do this, right? You can measure the same two variables on multiple individuals or measure the same variable, maybe that's a case where you probably want to know that, on two populations or entities. So let's dissect G first of all. What are the, we can, if we want, we can say there's, we're going to do the population one, we can do the second method. What variable do we have in that problem? Okay, we got a right answer down here. Let's have a right answer up there. What's the variable in that problem? Gender. I think that's what you said. So we have a variable, gender. And how many groups? So if we have multiple groups or another variable that we're measuring on everyone, we're okay. So what's the next step? You look at this and say, what else? What? Well, no, we're asking whether there's a second variable or. So we have one population, which is Bio 301D, which would say this does not satisfy the conditions necessary for us to evaluate whether there's a correlation present. And if you look up there, you can't come up with the second variable that we measured on everyone. So however you try and dissect this, there's not enough information. We're not saying there's a zero correlation. We're saying there's not enough data for a correlation to exist. This is G. Now let's look at F. Let's start dissecting that. How many variables do we see? How many think there are no variables in the problem? How many think there is just one? How many think there's more than one? Okay, what variables do you think? Do I get to pick on you? You can shake your head. Okay, he volunteered.
There's more than one blood type, much less within a.
Okay, so that's correct. There's actually two things we've measured. We've measured blood type A. I better do it up here. We have A and not A. And the other one is what? Plus and minus. I'm going to digress a moment. This might be, it's biology, but it might be practical. What does plus and minus refer to? This is real, right? You all know your blood type, something plus or minus. What is? What?
Isn't it RH?
RH. Anyone else heard of that before? It's called the RH factor. You know why it's called the RH factor? They first used, I think, rhesus monkeys to figure it out. What relevance is the RH factor to you in real life, outside the classroom, especially if you're female?
Pregnancy.
Okay, so a couple of you have heard of this. This goes back to the early 1900s. Even I wasn't around then, right? There's plus and minus, and at that early in the 1900s, there was a phenomenon where women would often give birth to stillborn kids or whatever, and they didn't quite know why, And they eventually figured it out. It had to do with this. This is a genetic trait in people. If the mom, this is not, don't write this down. This is biology. You're not going to be asked this again, but might actually help to remember it. If you're minus and you have a plus child, the first time around, you don't have this, what's called an antigen. It's something you build antibodies to, but the kid inside of you has them. Your body sees that and says, ooh, that's not good. I'm going to build antibodies against it, right? First kid's okay. But if you have a second child that's positive, now the antibodies you built to the first child start attacking that child. And so if you're a minus woman, your doctor is probably aware of that and will be telling you about this, but that's what this is all about. So anyway, that was a total digression that has nothing to do with the class, and it's probably 10 times more useful than anything you're going to learn in class. Let's go back to the problem. What do we have to put in? So we have two variables. So far, so good. We can potentially have a correlation here. Where do we actually have data to fill in the table? So here, okay, what number goes in here? 80%. We have something in here. So that's empty, and we have 20% here. So we have two variables in the, yep. Yep. Right. We have 65. We have nothing to go in either of these cells because we have not measured both variables on everyone. Right? So the only place we have the second variable measured is if you're A. We do not have enough information here either. So most of you got this answer right. Now, whether you went into this depth, I don't know. But once again, so this problem is slightly more complicated than G, and there is a second variable in the problem. It just hasn't been applied to a large enough fraction of the population, right? We need some down here for it to work. So I don't, and I'm not going to play games with you like filling in 3 cells and that. To be honest, when I set this up, I thought, yeah, this is easy. You can't graph it, so everyone will figure it out. And it was only one option anyway. We good on that? You want to? I'll give you another problem in a second. Something I saved over the years about some stunning facts about bread. So, number 2, fully half of all children who grow up in bread-consuming households score below average on standardized tests. Every piece of bread you eat brings you nearer to death. Long-term effects of bread eating. Of all people born since 1839 who later dined on bread, there's been a 100% mortality rate. Now, the first point is germane to us. More than 98% of convicted felons are bread users. Does that describe a correlation? I'm going to let you vote. After I clear this baby out. And the numbers are up there so you can, I guess I can let you read the whole thing. So you're dealing with the top one. Ooh, not a whole lot of people voting yet. Actually pretty close to last hour. Everyone got really confident, but about half the class was sure it was one way and half the other way. Okay, duke it out. That's close enough to equal that I'm not satisfied. Dissect it like we did before. Can you pull out two variables? Can you pull out two populations and one variable measured on both? Ask yourself that. Can you graph it? Try putting points down to say, you know, do I have multiple points on a graph? Do all of those. Get used to that. And then vote again. What, our cell phone batteries are all dead all of a sudden? Come on, vote. Okay, well, I badgered you into it. I think part of the issue might be that it's, for the most part, you're right. Or most of you are right, I guess. It might be difficult to decide you don't have enough information for a correlation. It's easy when there is enough information for a correlation. So let me do it as follows. Case A, suppose we had 98% of convicted felons, which is CFR bread users, 95% of not convicted felons are bread users. B, 98% of convicted felons are bread users. And C, these are not choices, these are three different examples I'm giving you. 98% of convicted felons are bread users. 98% of not convicted felons are bread users. So someone tell me how I can classify each of these three statements, or problems, if you will. What's the difference among these three? We'll just do this voluntarily. Easy?
One doesn't have enough information, right?
Which one?
It's the middle one.
Okay.
There's nothing to compare.
In this case, there's not enough information to decide if a correlation exists. That is correct. What about this one? Wait, this one? C. There is a zero correlation, or we say the same as no correlation. But you have enough information to decide one exists. What about here? Yeah, right? You've got two populations, each with the same variable, and they differ. Means a correlation exists. So this is, I've gone into this at probably about 4 times as much depth as I ever have in class over the years, and I guess it's because I never realized that this was difficult. And I gather from some of the blank faces and the fact that you're not on Facebook that it's still difficult. I heard the question, but I don't necessarily understand it.
Well, there's nothing in the problem that indicates the percentage of non-convicted felons bread use.
In which, oh, you mean here I made these up? Yeah. I made this up and I made that up. Yeah. And whoever wrote this, wherever the hell it went, whoever wrote this probably made it up too. So we started with this, and given that everyone's struggling, I thought maybe the reason is because you don't have the full spectrum of possibilities here. So I made up I added to this in these 3 possibilities. So this is what was given in the statement. There's not enough information to decide if a correlation exists. So I decided to give you problems in which there is enough information, and then to help you contrast, first of all, when there is and there isn't, but then also to contrast when there's enough information, but you have a correlation and you don't have you have a non-zero correlation. So there are really 3 levels here. Is there enough information? 2 levels. Is there enough information? Then if there is enough information, is there correlation, no correlation? You're first.
What determines when it's a correlation, like just 1%, if it's any different?
If it's any different.
Okay.
If it's identical, if you draw a line and it's absolutely flat, it's 0. If it's even a little bit tilted, I'm not going to play that game with you. But if there's any difference, you're golden. Same question? Now, we're not getting into statistics. I'm not talking about how much data you need to just, to measure correlation, what confidence limits are, and so on. I just want to focus on the basic. Is there an association? Is there not? You have enough information to even decide whether there's an association.
Professor, on the third criteria, you mentioned that you want correlations to be voluntary and variables must change together. So both of them change at
so all I mean is this. If you have convicted felons and non-convicted felons, and you got a data point here for whatever variable this is, we're going to call it y, as long as the line isn't flat, as long as I move from here to here, things go up or down, that is changing together. And of course, we're now into this at about 10 times more depth than I intended, but partly is I just didn't appreciate perhaps some of the subtleties here. What I want to go to, where we're going to now, and we'll come back and toy with this again, because I realize it's, sometimes you just need a little bit of time for things to sink in. What we care about is the following. Get my pages straight here. Is correlation versus causation. In order to understand this, you have to understand what a correlation is. Correlation is simply an association or a pattern. X and Y are associated. Causation. A reason for an association. If we say X causes Y, it means that if we actively change Y, X, the outcome Y, whatever it is, will change. I'm going to give you some explicit statements of this. So I'm going to contrast some statements here. Causation. Smoking causes lung cancer. If we smoke, our chances of lung cancer rise. That's what the statement means. Whatever our baseline rate. Correlation. Smokers have higher rates of lung cancer than non-smokers. And the point is, you might think, well, how else could they be correlated? We're going to talk about that later in the week. There could be non-smoking causes responsible for this correlation. There could in principle. I'm not saying it's true. I'm saying in principle. So that's one example, right? That is for lung cancer. A second example, causation. What we're looking for here is a verb, basically, describing this. Talking, oops, I misspelled that last hour, on cell phones while driving causes higher accident rates. What would be the equivalent statement for correlation, or the parallel, I should say, not equivalent? Higher accident rates. One more. Causation. Studying improves exam scores. Correlation is simply that people who study have higher exam scores than those who don't study. Now, I've purposely given you 3 examples here in which it seems obvious that the relationship is causal, but we're going to go into a lot that aren't. So why do we care? We nearly always want causal models. Because they tell us what we can change to achieve our goals. If the relationship between smoking and lung cancer was not causal, then we wouldn't do any good to quit smoking or avoid smoking if our sole goal was to avoid lung cancer. The problem that we're going to confront is that correlation does not imply causation. So we see a correlation. Doesn't mean that there's a causation there. In other words, it is a mistake to assume that 2 variables in a causal relation, in a correlation, are necessarily causally related. And the problem is further that people make this mistake all the time. Furthermore, I'll go into next time, our brains are hardwired to make this mistake. So on Wednesday, show up on time because we're going to do this quiz at the beginning of the hour.